divided them into 4 each day. So today we will be doing with the 4 different laws and 4 differences, and let us be thorough with the important questions of the physics from the subject General Science of Sslc questions. Okay, so the first important law is state Fleming's right hand rule, which is also called as generator rule. Okay, now what is this Fleming's right hand rule? The name itself suggests if the conductor is been held in the right hand, this is the conductor and it has been held in the right hand, such that the forefinger and the thumb will point in the direction of a motion. Okay, motion, and the forefinger will be in the direction of the field, that is magnetic field. The direction of the magnetic field around this conductor is been determined by this finger, and the middle finger will determine the direction of the induced current. What is induced current? The current which is produced by the phenomenon called as electromagnetic induction. So the direction of that induced current is determined by the forefinger if this is the conductor. The conductor is held in the right hand such that the forefinger points in the direction of the motion, the thumb points in the direction of the motion, forefinger points in the direction of a field, and the middle finger points in the direction of a induced current. Okay, so one thing you need to keep in mind while explaining this law is that first start up with the heading itself, like Fleming's right hand rule. If the conductor is being held in the right hand such that the thumb points in the direction of the motion, the forefinger is in the direction of a magnetic field, and the middle finger points in the direction of a induced current, and these 3 fingers are held perpendicular to each other. What do you mean by perpendicular? Thumb should be perpendicular to this, that is perpendicular means 90 degree. It's the thumb should be perpendicular to forefinger, and the forefinger should be perpendicular to the middle finger. Then only this law is been satisfied. So this is the Fleming's right hand rule, that is also called as generator rule. Now what is Dobrunner's law of triads? The name itself suggests you that triads means 3 elements. Okay, according to the Dobrunner's law of triads, if the elements are arranged in the increasing order, this is lithium, sodium and potassium. Lithium, this is 23, this is 39 and this is 7. Atomic masses. Now this is the example for the Dobrunner's triad. According to the law, if the elements are arranged in the increasing order of the atomic masses, then the atomic number of a middle element, that is a second element, will be the arithmetic mean of the first and the third element. Now what do you mean by arithmetic mean? That is, how do you calculate it usually? 7, take these two, add them. 7 plus 39, then divide by 2. The answer you will get is 23. So this is the example for Dobrunner's triads. You need to explain this in your own form, that when the elements are held in the increasing order of the atomic masses, then the atomic mass of the middle element is the arithmetic mean of the first and the third element. So this is the law on Dobrunner's law of triads. Now what do I mean by the other important law, that is Newland's law of octave. The Newland's law of octaves refers to the 8 elements, as the Dobrunner's law of triads refer to the 3 elements. Here octaves refer to the 8 elements. According to this law, the elements are arranged in the increasing order of the atomic masses same condition as that of the Doppler's law of triads, and if they are arranged in such a way, then the every eighth element will have the same atomic periodic functions as that of the first element. Imagine these are the 8 elements. Imagine these are the 8 elements. These all are arranged in the increasing order of the atomic mass. Then every 8th element will have the same periodic functions as that of the first element. This is the Newland's law of octaves. Okay, so we have finished with the 3 important laws. The last law for today is state Mendeleev's periodic law. The properties of the elements are the periodic functions of the atomic masses. It is very simple. The properties what the elements exhibit are nothing but they are the periodic functions of their atomic masses. Okay, so these were the few important laws. Totally till today we have completed the 8 important laws, and in the chemistry class we will be finishing up with the questions in the next class we will be finishing up with the passing package of the science by covering all the important laws and all the different and all the important differences as well as with the chemistry question. So 4 important laws I have covered here. So let me move to the important differences. The important differences are, first is oxidation and reduction. Now the name itself suggests you what is oxidation and what is reduction. Oxidation means addition of oxygen, and when the addition of oxygen takes place, the removal of hydrogen takes place. Okay, vice versa. If the addition of oxygen is taking place, then then the removal of hydrogen takes place, and in turn hydrogen consists of the negative charges that are called as electrons. If the hydrogen is been removed, then the electrons are also removed. Let me explain you. In oxidation, oxygen is being added, hydrogen is being removed. Hydrogen consists of the negative charges which are nothing but electrons. If hydrogen is being removed, even the electrons are removed. So these are 3 important differences between oxidation and reduction. The oxygen is being added, the hydrogen is been removed, the loss of electrons takes place. So the opposite of this is reduction. Removal of oxygen takes place. Removal of oxygen, addition of hydrogen, addition of the electrons, that is the negative charges. So this is the important difference between the oxidation and the reduction. The other important difference is between the arteries and the veins. Now, the main difference between the arteries and the veins is arteries carry the blood away from the heart. Away from the heart means after the purification, the tube-like structures which are responsible for carrying the blood from the heart to the all other body parts, it is arteries. Arteries perform this function of carrying the purified blood from the heart to the other body parts, whereas veins do the inverse function, that is they carry the impure blood from all over the body towards the heart for the purification. Now if this is happening, then logically we can think that the flow of blood is fast in arteries. Why? Due to the absence of impurities in it. And whereas in the veins there are impurities because the blood is being carried from all over the bodies, so there will be some impurities because of which the rate of flow of blood in veins is slower than compared to artery. The first important difference between arteries and veins was arteries carry the blood away from the heart, whereas the veins carry blood towards the heart. Whereas the flow of a blood in the arteries is faster, whereas the flow of a blood in the veins is slow. Okay. Now the other important difference is between the concave and the convex mirrors. Okay, let me tell you, if you are remembering the difference between the concave mirror and the convex mirror, better remember it once. So better remember it one type of a difference, so that it is easy for you all to not to get confused and remember it. The difference between the concave mirror and the convex mirror is concave mirrors are converging, whereas the convex mirror is diverging. The opposite the opposite can be applied to the convex lens and the concave lens. Concave lens are diverging, whereas convex lens are converging. It is opposite. So remember it once. One type of a difference, that is the concave mirrors are converging and the convex mirrors are diverging. Okay. The other important difference between the mirrors are inner surface act as a reflecting surface. Now what do you mean by inner surface? Concave refers to the formation of a cave in a mirror. This is concave mirrors. Okay. Now the inner part acts as a reflecting surface. Reflection means bouncing back of a light. When the light is been passing here, if it is a concave mirror, then it will reflection will take place at the mid of the inner surface of the mirror. Whereas for the convex mirrors, it is the vice versa. The outer surface acts as a reflecting surface. Concave means cave-like form. Convex means it is like this. The outer surface. This is the outer surface here. Now you might ask me, what is the difference? The concave mirrors are in the cave-like form. The reflecting surface will be in this curved part, whereas for the convex mirrors, the converging and the reflection all takes place here. This is the outer surface of the curved part will help you in reflecting the lights. Okay. So these concave mirrors are converging and they are used in headlights of the vehicle, whereas the convex mirrors are used in the rear view mirrors of the vehicle. So these are the important differences between the concave mirror and the convex mirror. Concave mirror is the converging, whereas convex are diverging. The inner surface of the concave mirror acts as a reflecting surface, whereas the outer surface of the convex mirror acts as a reflecting surface. The concave mirrors are used in the headlights of the vehicles, whereas the convex mirrors are used in rear view mirrors of the vehicles. Now what is the difference between the concave and the convex lens? As I said, it is vice versa. The concave mirror was converging, so concave lens will be diverging. Convex mirror was diverging, so convex lens will be converging. Okay. The other important difference between them is it is a thin in the middle, concave, right? As I said, this is the surface of the concave mirror of the lens. So the edges is going to be thick, whereas the middle part will be thin. Okay. So the vice versa is for the convex lens. The middle part will be thick, whereas the edges will be thin. Concave lens always produce a real and inverted image. Inverted image means upside down, whereas for the convex lens, they produce real and virtual image. Virtual means the image of the object will look like as same as that of the object itself. If this is the object, the same will be the image of this object will be as same as that of this object itself, because it is not going to show you inverted form, whereas the concave lens will show you the inverted form of the object. Okay, so these were the important differences where important differences and the important laws. Now let us move on to the physics part. Now the first important question is, what is electric power? Electric power is nothing but a rate of electrical energy transferred by an electric circuit per unit time. Okay, let me explain you. What is, if someone is telling the power in a circuit, then you need to define it in this way. It is the measure of electrical energy. Unit time means in a 1 second. If this is the circuit, let me draw it. This is the battery, this is the switch. Okay. So, if this is the circuit, the measure of electrical energy that passes from here, from the battery, from the positive end, from the battery, and reaches the bulb. So this is the entire circuit. Okay, if the light energy, if the electrical energy is been passing through the circuit in 1 second, how much of the electrical energy passes? How much of the electrical energy passes through this circuit in just 1 second refers to the power. What is power? It is the measure of electrical energy that passes through the circuit in per unit time. The per unit time refers to 1 second. Okay. So this is the definition of the power. What is electric current? Electric current is produced due to the movement of stream of electrons. Okay. Now what are the electrons? Electrons are the negatively charged particles. If these particles moves through the conductor, then it constitutes to the current. The movement of the stream of electrons constitutes to the current. Now what is the resistivity? Resistivity, I think I have explained you this in the previous class. When I was explaining you the difference between the resistance and the resistivity. So I think I need not repeat this because it will be wasting your precious time. So let us move to the important definitions, such as 1 ampere. Now what do you mean by 1 ampere? It is the ampere is the SI unit of a current. So 1 ampere refers to when 1 coulomb of charges. Now what do you mean by 1 coulomb? Coulomb is the SI unit of the charge. Okay, 1 coulomb. Now 1 coulomb consists of how many electrons? These are 1 coulomb constitutes to 6 into 10 power 18 electrons. Now what does this value means? That means 6 into so many zeros, 18 zeros, and if you multiply this 6 with these zeros, what answer you get? So many electrons constitutes to a 1 coulomb. If these electrons are passing through the conductor in a unit time, that is per second. In a second, if in a conductor, imagine this is the conductor. This is the conductor. In 1 second, 1 coulomb of charges has been passing through. The movement is 1 coulomb of 1 coulomb of charges in 1 second, which determines the current which is produces 1 ampere. If 1 coulomb of charges is being moved through a conductor for 1 second, then the current which is produced is 1 ampere. So what do you mean by 1 coulomb? I said 1 coulomb refers to 6 into 10 power 18 electron. This is the value. And what do you mean by 1 volt? 1 volt is the potential difference. Volt is a SI unit of potential difference. And if 1 volt is the potential difference between 2 points in a current carrying conductor, when the 1 joule of work is done to move a charge of 1 coulomb from one point to the another point. Okay. Now let me explain you. This is the 2 points. in a conductor. 1 volt refers to 1 joule of work done, 1 joule of work done to move 1 coulomb of charges. Now here 1 coulomb of charges have been there and it has to move from one point to the another point. The work which is done to move this 1 coulomb of charges from one point to the another point refers to 1 volt. Okay, so this is the definition. The 1 joule of work done to move the 1 coulomb of charges from one point to the another point, then the potential difference which is produced between these 2 points is 1 volt. Okay, let me again repeat it. If the 1 joule of work has been done to move the 1 coulomb of charges from one point to the another point, then what is the potential difference between these 2 points? It is 1 volt. Okay. Now what is 1 ohm? 1 ohm is the potential difference across the 2 ends of the conductor is 1 volt and the current through it is 1 ampere. 1 ohm. Ohm is the SI unit of resistance. Now if the potential difference between these 2 points is 1 volt and the current passing through these points is 1 ampere, then the resistance between these 2 points is said to be 1 ohm. Simple. So if the potential difference between the 2 points is these points is 1 volt, then the 1 volt and the current passing through that points is 1 ampere, then the resistance between these 2 points is 1 ohm. Now what is 1 watt? 1 watts refers to 1 watts is the power consumed by the device that carries 1 ampere of current when operated at a potential difference of 1 volts. Okay, 1 volt, 1 watts refers to what is 1 watt? If 1 watt of a power is being consumed, if someone says that this device consumes 1 watt of the power, then it means that it carries 1 ampere of current. This device carries 1 ampere of a current when it is operated at a potential difference of 1 ampere. Okay. So what do you mean by 1 watt? 1 watt is the potential, 1 watt is the current, 1 watt is the power that is consumed by the device when it consumes 1 ampere, when it is operated at a potential difference of 1 volts. Okay, so 1 watt is a simple thing that if the device is been operated at 1 ampere and 1 volt, then the power which is consumed by the device is called as 1 watt. Okay. Now what is the how many of watts constitutes to a 1 kilowatt? It is 1000 watts. And what is 1 kilowatt per hour? The 1000 watts makes up the 1 kilowatt, and per hour means how many of the seconds involved in the hour. 1 hour, it consists of 3600 seconds, and if you multiply with that, 1000 watts into 3600, then 3.6 into 10. Okay, so this refers to 1 kilowatt per hour. Now what are the practical applications of heating effect of electric current? It is an electric bulb which consists of a heavy metal called as tungsten, which have a high melting point. High melting point is important in a bulb, so that if it has a low melting point, then it will lead to many hazards. So it is better to use the high melting point metal in a bulb. Okay, and this bulb is employs the principle of heating effect of electric current. Okay, now the other Application, practical application is fuse. Fuse consists of the piece of wire made up of a metal or an alloy. What do I mean by alloy? Alloy refers to the homogeneous mixture. So homogeneous. What do you mean by homogeneous? You cannot differentiate the constituents in that mixture easily. Homogeneous completely. Okay, now homogeneous mixture means if you are adding in a milk some sorts of the protein powder or something, then whatever, if that constituents cannot be differentiated, then it is known as homogeneous mixture. And if you can make out what constituents are there in that mixture, then it is known as heterogeneous. The homogeneous mixture of metal is known as alloy. The mixture of the metals in which you cannot differentiate the constituent metals, then it is known as alloys. Okay. Now, in the piece of a metal which is made up of the piece of a wire which is made up of either a metal or an alloy is present in the fuse. Now, what does it do? It is always connected in series in order to prevent the short circuits. If the overloading is been occurring and then there is some problem in a circuit, then this wire will have a very low melting point, because of which it will break the circuit and prevent the further supply of a current. This is how the fuse works. Okay, these were the two important practical application of the heating effect of electric current. Now, the other chapter is magnetic effect of electric current. So let me explain you that. Now the first question is properties of the magnetic field lines. Now what are the magnetic field lines? They are the imaginary lines formed around a magnet. Okay? Or they are the imaginary lines that are formed in the magnetic field. If this is the magnet, and these are the lines, magnetic field lines, they will determine the strength of the magnetic field. The closer the distance between the two magnetic field lines is less, then it means that the strength of the magnetic field is very strong. Okay. So these are the magnetic field lines. The property says that they don't intersect. Why don't they intersect? If they will intersect, then that means that at that point the magnetic field is having two directions, which is not possible. So magnetic field lines never intersect, and they originate from the north and ends at the south outside the magnet, whereas inside the magnet they will come back here, originate from the south and ends at the north. So they are forming a closed loops, right? Their first point you need to write is they form the closed loops. They don't intersect. Why don't they intersect? Because at that point, if the two magnetic field lines intersect, then at that point the magnetic field will have two directions, which is not possible. So hence the magnetic field lines don't intersect. Now you will write the direction. The magnetic field lines originates from the north and ends at the south outside the magnet. Inside the magnet, they originate from the south and ends at the north. So these are the properties of the magnetic field lines, and they are the vector quantity. Now what do you mean by vector? Vector quantity refers to they are having both magnitude and the direction. So they are known as vector quantity. So these are the important properties of the magnetic field lines you need to mention when the question is being asked. Now, what is the magnetic field due to the current through a straight conductor? If a current flows upwards, then the direction of a magnetic field will be anti-clockwise. So if you can't remember it in the practical form. So this is the conductor. If the current is flowing upwards, then you hold it like this. You see how these curved fingers are. If it is upwards, take it like this and see it from your eyesight, that how does this curled fingers are looking. It will be in an anti-clockwise. Normally the clock will work like this. From 12 it will start, and if it goes in a reverse form, then it is anti-clockwise. If you take the conductor, if you hold a pen or a pencil and look like this, then the fingers will be in anti-clockwise. This will determine that the direction of the magnetic field in a straight conductor when the current flows upwards is anti-clockwise. Whereas if the current is flowing downwards in a straight conductor, then if you hold like this, the direction of these curved fingers will be in the clockwise direction. So this is the direction of the magnetic field. So these are the two important points. If you need to mention if the question magnetic field due to the current through a straight conductor is been asked. Now what do you mean by the factors affecting the strength of magnetic field around a straight current carrying conductor? Now what are the factors that affect the strength of a magnetic field? Strength of the magnetic field refers to how strong that magnetic field is or how weak is that magnetic field. Then there are two factors. The first factor is the magnitude of the current. If the more current is being passed through the conductor, then the magnetic field produced around that conductor is also strong. And if the magnitude of the current passed through a conductor is low, then it means that the magnetic field produced around the conductor is weak. That means that it is directly proportional. Proportional means it is directly dependent. If that increases, even this increases. Directly proportional means that directly proportional to magnitude of current. Now inversely proportional to the distance between the conductor and the magnetic field, current carrying conductor and the magnetic field. If the distance is inversely proportional. To distance. Magnitude of the current. If the conductor is having the more of the magnitude of the current passing through it, then the magnetic field around that conductor is strong. Whereas if it will be determined by the distance, as I have mentioned you earlier. If the magnetic field lines are having more distance between them, or they are much far away from the current carrying conductor, then the magnetic field, as it goes away from the conductor, it will decrease. This is the conductor. This is the conductor. The magnetic field here will be strong, whereas here will be low. Here will be low because it is much far from the current carrying conductor. Okay. So these are the two factors that affects the strength of the magnetic field. Now, how does the formation of the magnetic field is the current in a solenoid? Now, solenoid will act as a magnet, bar magnet, where if it is acting as a bar magnet, the bar magnet will have two ends, that is the north pole and the south pole. Okay, this north pole and the south pole. When the magnetic field is set up around a solenoid similar to the bar magnet, one end of the solenoid acts as a north pole and other acts as a south pole. Magnetic field is represented by a straight magnetic field lines parallel and very close to each other, same as that of the bar magnet. If this is the solenoid, one of the end will act as a north pole and one will act as a south pole. Now Now what is the solenoid? Solenoid is something, if on any conductor, if the wire is being wound like this, then and the current, and it is connected to a battery and a switch, if the current is being passed through the solenoid, that if the current is being passed through this wire, then this will act as a magnet. One end of it will act as a north pole and one end of it will act as a south pole, because of which the formation of magnetic field lines takes place. So this is the magnetic field which is formed around a solenoid due to the current. Now the other important question is the electromagnetic induction. As I have said, the current that is produced due to the magnetism, the current which is induced in a conductor due to the presence of magnetism is known as electromagnetic induction. Now electromagnetic induction was found by Michael Faraday, and the direction of the induced current can be found by the Fleming's right hand rule. As I have said, if the conductor is been held in the right hand, then the thumb will point in the direction of the field, direction of the motion. The forefinger will point in the direction of the field, and the middle finger will point in the direction of the induced current. Okay. Now the other important questions is the Faraday's experiment, where he took a wire, a bar magnet, and a galvanometer. He took the wire on one of the substance. He wounded the wire. He took the wire, wounded, connected that to a galvanometer, which says about the presence and absence of the electric current. Connected to the galvanometer, took the wire, connected to the galvanometer and bar magnet, and this is the deflection. If this bar magnet is being pushed into this wire, into this coiled wire, then this movement, as soon as it is moved, the direction of the deflection in the galvanometer will be this side, and if it is withdrawn, the direction of the deflection will be the galvanometer opposite sides. That means that the movement that means that the current is being induced in the coil only when the magnet is being inserted into the coil. When the movement of the magnet in a coil and out of the coil is determining the presence of current. If it is held still out of the coil, then there is no deflection seen in the galvanometer, which means that the movement of the bar magnet into the coil is producing a current which is called as induced current. Now the other important hazards here are electric fuse. As I have explained you what is electric fuse, it uses the wire which is made up of a metal or an alloy which have a very low melting point, and it breaks up when there is a disturbance in the circuit or some overloading occurs or the short circuit occurs. It will break the circuit in order to prevent the further flow of a current. Whereas the other important hazard is that overloading. What is overloading? Is due to the increasing voltage, or if the live wire and neutral wire comes in contact. When too many appliances are being connected in one socket, then the overloading appears due to the sudden increase in the voltage, and because of this the live wire and the neutral wire comes in contact, which leads to the short circuit and further the fire and other damage. So this is the end of the magnetic field, the chapter called as magnetic field, magnetic effect and electric current. The next chapter is light reflection and the refraction. Now what do you mean by the reflection of light? The phenomena of the bouncing back of the light from the surface, from the smooth surface when it is held in the same medium. If this is the surface and it is been held in the same medium, that is air, the light is coming, striking this medium and bouncing back, then this phenomena is called as a reflection of light. So what are the characteristics of the image formed by the plane mirror? It is virtual and it is erect and same size as that of the object. It is erect and it is same size. The size of the object will not vary if it is viewed under this plane mirror. And the distance of the object from the plane mirror is same as that of the distance of the image from the plane mirror. That means that the distance between the object and the distance between the image is same. Now the other is it is laterally inverted. Laterally inverted means side by side inverted. Inverted refers to upside down. If this is the object and if it is viewed in some mirror, if the object appears like this, then it is said as inverted image. And what do you mean by the lateral inversion? If I am holding like this, if I am holding the pencil and the duster in this way and I am viewing in the plane mirror, then in the plane mirror it will be viewed like I am holding the pencil at this side. So this is known as lateral inversion. The change in the left and the right side will refer to a lateral inversion. Now the other terms which are related to spherical mirrors. What are the important terms that you have to keep in mind while you are dealing with the spherical mirrors are center of the curvature. What do you mean to say? You can take the meaning right from the heading itself. Center of the curvature. Curvature means curved part of the mirror. The center part. If this is the mirror, spherical mirrors, right? So if these are the spherical mirrors, the central part of the curved mirrors will refer to center of the curvature. Now what is the radius of the curvature? The distance between the pole. What is pole? It is the midpoint of the spherical mirror. Midpoint of the spherical mirror is known as pole and the distance between them is known as radius. Okay? Radius of curvature. Pole refers to the midpoint of the spherical mirror. Now what is focus? It is any given point. It is the point where all the light rays coming parallel to principal axis converges. Now the light rays are coming. Okay, and this is the focus. Imagine this is the surface and the lights have been coming here. Many light rays are coming. At one point, all the light rays will converge. This is known as focus. This is the principal axis. The distance between the pole and the center of curvature refers to principal axis. Parallel means they are not going to meet. Okay? They are coming parallel to principal axis and they are converging at one point. Then that point is known as focus. Now what is focal length? The distance between the optical center and the principal focus. Optical center, that is the pole. What is the distance between the optical center and the principal focus refers to focal length. Now these are the important terms that are related to the spherical mirrors. Now what are there are tables in your textbook, that is the image formations via concave mirror and the convex mirror. So you need to remember all those. Better remember the one which have the different behavior than the other. For example, the image formations by the concave mirror, in the nature of the image for all the positions is real and inverted. Only for one condition, the nature of the image is virtual and erect. Remember that one, so that if you some other is coming, then the nature of the image will always be real and inverted. Remember it in that form. Now, what are the uses of the spherical mirror? Spherical mirrors. Concave mirrors are used in torches and in the headlights of the vehicles, in the shaving mirrors, in the dentist mirrors, and in the solar furnaces. Whereas the concave mirrors are used in the rear view mirrors of the vehicles. Now, let us move to the other part called as refraction of the light. What do you mean by refraction? It is the phenomena of bending of light when the light rays passes from one medium to the another medium. Now, this is the water in a beaker. If the light passes from the air medium and reaches the water, the light rays will bend. This is known as refraction. The light rays are passing from here, from the air medium, and bending. It would have gone like this, but it is not going. It is bending like this. This phenomena is known as refraction of light. Now, what are these terms? There are sign conventions of the lenses. You need to remember that. So this is the end of the chapter called as light reflection and refraction. For the passing package, you need to remember these points. Okay. So what is the other chapter in the physics? That is the human eye and the colorful world. What do you mean by power of accommodation? It is the ability of an eye to adjust the focal length. It is the ability of an eye to adjust its focal length. Then it is known as power of accommodation. The ability of an eye to adjust the focal length is known as the power of accommodation. Now, in a normal vision, if someone is saying that you are having a normal vision, then what does it mean? It means that the near point of your eye is 25 centimeter, just 25 centimeter. That means that near point means if you are taking any of the picture and you are holding at 25 centimeter distance, then only you can be able to view that image. If you are holding at 23 or 20 centimeter, then also you will not be able to see that image. That is known as near point. Now, what is the far point of the normal vision? It is infinity. Infinity means there is no end. The eye can see beyond anything. Okay, for far distance, it is known as far point of the eye. Now, what are the defects of vision and their remedies? What are the defects? The defects are myopia, hypermetropia, presbyopia, and cataract. Now, what is myopia? Myopia is a nearsightedness. Nearsightedness means you are able to view the objects which are near to you, but not the objects which are far from you. Then that means that you are having a myopia. Now, why does that occur? When your far point is nearer than the infinity, that means that in your eyes the far point has changed from infinity to that of a near. Near means if the far point was infinity, right? If that point has been changed and it is near the far point of your eyes is nearer than the infinity, then this defect occurs. Now, another reason for this myopia is excessive curvature of the eyelids. Excessive curvature means the curved part of the lens is been increased. Then also this defect of the vision occurs. The other reason is elongation of the eyeball. If the eyeball has been elongated, then also you will suffer from the defect of the vision called as myopia. Now what can be the remedy? Use of concave lens of suitable power will help you overcome this defect of vision. Now the other defect is hypermetropia. Now what is hypermetropia? Hypermetropia refers to the condition where a person is able to see the far objects but not the near objects. Now why does this occur? This occurs when the far point has changed. Here the near point would have changed and it would have gone much away from the near point. If the near point of a person has changed from 25 to 30 centimeter, then the person will be affected from the defect of vision called as hypermetropia. Now the focal length of the eye lens is too long. If the focal length of the eye lens, the length of an eye, the focal length has been changed and it has become too long, then also the person will suffer from the hypermetropia. Now eyeball has became too small. If the eyeball has become too small, then also the person will suffer from the hypermetropia. How can it be overcome? Then use of the convex lens of the suitable power. If you are using the convex lens of the suitable power, then also you can overcome from this defect. Now what is presbyopia? Presbyopia refers to the condition where the power of accommodation of the eye usually decreases. That means that the ability of our eye to adjust the focal length is decreasing. Why does it increasing? Why does it decreasing? Due to the aging. It is seen in the aged people. Because at that age the near point gradually recedes away. Recedes away means that the near point is going away from the actual point, that is 25 centimeter. It is receding away from that 25 centimeter, which is leading to a cause of presbyopia. Now why does it occur? Actually, why does it occur? Due to the diminishing flexibility of the eye lenses. If the flexibility of the eye lenses has been damaged or it is diminishing, then also the person will suffer from the presbyopia. The remedies for this is the common type of the lens is called as bifocal lens can be used in order to overcome this presbyopia. Now what is cataract? The partial or complete loss of vision. Why this partial or the complete loss of vision occurs? The crystalline lens of the people at old age becomes milky and cloudy. At old age, the crystalline lens of the eye becomes milky and cloudy, because of which the old people will not be able to view. The old people will not be able to view the objects clearly, or they will not be able to view the object itself. Partial or the complete loss of vision occurs due to this process, and this is possible to be restored in this defective vision. The vision can be restored through a cataract surgery. If the cataract surgery is performed, then only the person can overcome from this defect. Now what are the other important questions in this chapter is, why do stars twinkle? Now the stars twinkle because due to the different stars are very far from the planet. That is, they are very very far from the planet, because of which the light which is emitted by the stars would have to pass through the different types of atmosphere. Different types of atmospheres which consist of different types of gases at various temperatures, because of which the deflections, whatever that light from the stars undergoes, that will make the star appear twinkle. Now what does that mean? Okay. This These are the various atmospheres. This is the star. The light is coming, passing through various atmospheres. Some of the rays of the light will appear faster to will approach faster to our eyes, whereas some of the light rays from the stars will approach later to our eyes, which makes it appear like a twinkling. Now, why the planets do not twinkle? First of all, they don't emit the light as that of the stars does, and the planets are much nearer to the Earth as compared to the stars. So, due to the change in distance, the light is also not emitted, and they are not placed very far from the planets. So, the planets do not twinkle. Okay. Now, why does the sun appear reddish early in the morning? At the time of sunrise and sunset, the sun rays have traveled a longer distance due to the curvature of Earth. At the sunrise and the sunset, the rays of the light, which have both the blue light and the red light, would have to travel a longer distance. Now, in these two lights, the blue light is having a shorter wavelength. Shorter wavelength means shorter wavelength, the scattering power of that blue light is lower than compared to the red light. So, as it is traveling for a longer distance, the rays are traveling for a longer distance, the blue light of the rays is scattered away due to its shorter wavelength, whereas the red light is having the longer wavelength, because of which it reaches our eyes by traveling a longer distance. Now, why does the sky appear dark instead of a blue to an astronaut? Because there is no atmosphere containing air in an outer space scatters sunlight. Since there is no scattered light to reach our eyes in outer space, the sky appears to be dark. Now, in the outer space, there is no atmosphere present in order to scatter the sunlight. So, in Earth we are having the atmosphere, because of which the light is being scattered in a different way, and we are able to see the different colors of the sky. But there we are not having any atmosphere to scatter the sunlight, because of which the astronaut will see the dark sky instead of the blue sky. So this ends the important questions of the physics. Now, in the next class, I will be carrying out with the chemistry passing package, along with the remaining the important laws and the important differences. So, I think this session was helpful for you all to prepare for your examinations. Be calm and enjoy your learning.